Let's look at an interesting way to combine two functions to get a new function. This is called composition of functions. So we're going to take f and compose it with the function g. And it's f open circle g, and that function is called f of g. So this function is f of g of x, and it's defined as f with an input of g of x. So if I were to draw this as a machine, it would look something like this. X is the input going to this big machine, f of g, looks kind of like fog. So x comes in, and first x goes into the machine g. And then out of that comes g of x, because x went in, g of x comes out, and then that goes into the machine f, and out of that comes f of its input, which was g of x, and that is f of g of x. Okay, so x has to go into g, and then g of x has to go into f to go this way. So up here, you kind of work inside out. X goes into g, and then that whole thing goes into f. Okay, so let's practice. Here we have two functions, and we want to find f of g of 1, so I'm writing it differently. The first thing I want to do is plug 1 into g, so I go up to the definition of g of x and I plug 1 in everywhere there's an x, and so this is the same thing as f. I'm just copying the f down and replacing the inside here, g of 1. G of 1 is 1 minus 3, which is negative 2. Now I plug the negative 2 in everywhere there's an x in the f function. So negative 2 goes into f, and then I get 2 times negative 2 plus 1, which is negative 3. So f of g of 1 is negative 3. Here we've got two functions. I want to find f of g of x and its domain. So f of g of x means I need to take the g of x part, which is square root of x minus 1, and plug it in here. So I'm just replacing g of x with its output. And then I need to substitute this as my input to the f function. So everywhere there's an x here, I need to substitute it in. So I've got 2 over the square root of x minus 1 squared. I always recommend literally showing this step. I'll explain why in a minute. And when you square a square root, the square root goes away. So you end up with 2 over x minus 1 as your final function. To find the domain, just like when we added and subtracted functions, you need to consider the first step where both functions are shown. That's this step right here, because it's got the f function, 2 over something squared, and it's got the g of x function, square root of x minus 1. So in this step, do we have any restrictions? Well, sure. The denominator can't be 0. When you square it, you just get x minus 1, can't be 0, so x can't be equal to 1. So there's one restriction. The other restriction is you have a square root, and you know in any even root, the radicand, the thing under the radical, has to be bigger than or equal to 0. So x has to be greater than or equal to 1 is the second restriction. Alright, so we have to combine the two restrictions to find our domain. We have to throw out anything that can't be included, so x can't be equal to 1, but it's greater than or equal to 1. So if you graph that on a number line, here's 1. We know that x can be bigger than 1, and this says it's or equal to, but this one says it can't be equal to, so we have to throw it out. So I'll put an open circle there, and that is the domain. So in interval notation, the domain is parenthesis 1 comma infinity. So the domain is anything bigger than 1.